I just wanted to show you what I got going on here. What I did was I printed this, 3D printed this one part that goes on top. It rotates. It gets attached to the table and it rotates the whole top unit. And I thought I had it right, but I got a little error here. I went to the website for SDP and I found the biggest gear they had, which was 5-inch 0.091 pitch diameter. So I patterned everything off of that, and then I 3D printed this part, and the belt doesn't fit. Now what I'm doing is I'm running this belt inverted. So here at the bottom, well, it doesn't matter top or bottom, but this one side, see, the belt fits pretty good here. But then as you go along the side, it starts to skip. See, back here on this one side looks pretty good, then it starts to skip over here. You go along the side here, then it starts to go back, making contact. Then I have it going into the unit around the motor, and on this side it's the same thing. It fits pretty good here, and as you go along the side it starts to skip. Then when you get back to the bottom, it goes back in. These are just weights I got holding it down. And the afterthought is that this is another belt, but I think what's going on here is that the pitch diameter of the gear is just like this with the belt on the outside. Then when you fold the belt to the inside, it made it smaller. So I think we have, now it's skipping here. It's like using a thread pitch gauge. You can see it, you know, when you're using a thread pitch gauge, you can tell because the threads, they start going off, whether you're too big or too small. So I think what happened here was that when I inverted the belt, it actually made it smaller because I'm riding on the inside of the pitch diameter instead of the outside of the pitch diameter. So what I'm going to do is I'm going to take away 2 of the teeth on this 3D printed part and see if that helps. And I'm going to reprint it, but of course I'm not going to make it like it should be. I'm just basically going to print the pattern to see if it works. There's no point in printing this whole part until I find out it works. This part took 6 hours to print, and I thought that it was going to work, because what I did was I patterned the spacing of these parts per the drawing, and then I rotated the pattern until I got the proper spacing of 0.200. So I don't remember if I added teeth to it, or I just kept playing with the number of teeth that it was putting in there, and I got it to where the spacing was 200. But for some reason it didn't work. I'm not an engineer, so I really don't know why it didn't work, but I just put it on here, and it looks like that there's too many teeth on here. So I'm going to take, looks like, it's skipping on this side and it's skipping on this side. So I'm going to take one tooth off of here and one tooth off of here. So I'm taking 2 teeth out of the whole pattern, and we'll see how that works out. So when I look at this part, this is actually the way it goes, like this, with this side being up. Just got to rotate. And there's going to be a gear here. It's going to rotate it. Now I ordered these belts. This is the belt I ordered. And I was just guessing at the size, my best guess. And it seems pretty close, but I won't know until the length of the belt, until I actually get it to fit inside of here. And I ordered this. I was going to order these gears for the motor. I got the motor. That's a cute little thing. Small motor, but it's heavy. This is what I ordered. It's supposed to be 84 ounces of torque. Actually, I got 2 of these. One's going to drive the top circular, and the other one's going to drive the whole unit from 90 back to horizontal. So if you want to do work on it, on the side of the part, you just flip it up, and then this will rotate. Then you go back to horizontal if you want to do work on one end of it, or rotate it any amount of degrees in between, and rotate it 0, 180, whatever you want, depending on what you want to do to the part. So this is the motor. I don't know how much it weighs, but it's a lot heavier than I thought. Like I said, I got 2 of these. And I went ahead and I got the bearings in. These are going to mount to the side. There's going to be one on each side, and so the unit can pivot from horizontal to vertical. So I got 2 of these, and I made these pieces here to capture the bearing. There's going to be one on each side, I got a press fit on here, so that's why it's not going in. But that's going to go like that. There's one on this side, and one on the other side. And these holes, I got a 2-inch square tubing that I already drilled out to accept these bearings. And I have the blocks that's going to fit on the side of the unit. I haven't finished them yet, I just got them to size. So these blocks are right now they're well, they're supposed to be 1 3/8, but the material I had was a little under 1 3/8, so they're about 1 5/16 right now. I was trying to hold them as thick as I could, but the material I found didn't allow it. So they're 2 inches wide. Well, this is going to be the height of it, 2 inches, because it's going to sit like that, standing up. This is the width. The width isn't finished. It's just a saw cut. But right now it's at, I need it to finish around 3 inches. Right now I got, I don't know, 3.5 inches. But yeah, it's going to get 4 mounting holes. Going to be some mounting holes here. They're going to be counterboard. Then there's going to be some holes here that are going to mount this to the bearings. It's going to be a little piece that comes up vertical from here up. Then the bearings are up here. And this unit, like I said, gets mounted to the circular part, which is going to rotate. And what I was saying about this this pulley, I was going to order these pulleys, and then I saw where the SDP, they have this pulley stock. And I thought, well, that's even better. It's because you can cut it and you can turn it and you can do what you want with it. So what I want to do is I want to attach it to the motor. Going to drill a hole in it. Attach it to the motor. And what I'm basically going to do is, this is the motor shaft. So I'm going to have a big piece here so I can put a set screw in it. This is actually the gear part. I'm going to turn a pilot on the end, like a bearing. So this will work out real good. Yeah, I didn't realize they had that, and as soon as I saw that, I grabbed it. Yeah, the only thing is, it's like 30 bucks. These pulleys, I don't know whether they cost 10 or 12 bucks. But you know, these pulleys, they have these guards on the side. So I was thinking, well, if I have to put some kind of guides or guards to keep the belt in place, I can just put a snap ring groove in there. I just put a snap ring in there, and that'll keep the belt in place. But these are just things I'm throwing around right now, and I was thinking, well, on the top, how am I going to attach my parts? So what I was thinking was, this is patterned after a that little vise that's got the little set screw in, not the set screw, but the bolt in the back, and it tightens down on an angle. I forget the name for it, but they're usually 4 inches long or 6 inches long, and they're about 2 inches wide, maybe 1 inch wide. And they're made out of steel, you know, a little precision vise. And I was going to mount that to the top, but I got one, and the thing is heavy, too heavy. It doesn't have to be that heavy. So I made this out of aluminum. And what I'm going to do is I'm going to put a steel insert in here, and it's going to be bolted in the back and probably bolted on here. Then I'm going to have to make the other part, the other jaw. This is going to be the back jaw. Of course, there's going to be a piece of steel here, and I'm going to put a little groove in it to capture the material, and have the other jaw on this side, and it's going to slide back and forth. I'm going to have to put a groove in here, and it's going to have a groove in it to capture the part. Then over here, I guess I'll put some circles in here, put like a dowel pin with a thread through the center, so I can move this jaw back and forth, and then lock it down, and it'll lock down on an angle to keep the piece onto the surface so it won't lift up. So that's what I was thinking. I gotta finish this part. Just got it started. But hey, you gotta start somewhere, right? So the next thing, the most important thing, is to finish. I gotta get this guy. Gotta get this guy fixed. If I don't fix this guy, the unit won't work. So I gotta do this first. So, like I said, I'm gonna go ahead and go back in the CAD system and take out 2 teeth, and then run it on the 3D printer again. Just basically running the teeth. I'm not gonna run the width and the height. I'll probably make it 1/4 inch high, just to get the pattern right. But you know, that's where we are. All right, talk to you later. Bye.